Tiende pamoja ni mtima umo. 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 Tiende pamoja ni mtima umo.
Hello everybody and welcome to MTN TeleSchool. My names are Mutakela Inutu from Lusaka Girls Secondary School. I'm pleased to be on this MTN platform where I get to have this opportunity to revise with you. I'm a specialist in science, but in this platform, I'll be specialized in chemistry. In this session, we'll look at a few questions coming from 2016 General Certificate of Education past paper. So sit back and enjoy the lesson. Question number 1. All matter is made up of small particles which are referred to us as the basic unit of matter. The small particles of matter are always in random motion. First of all, you need to understand what matter is. When we talk about chemistry, there's no way we can avoid this term matter. So matter is any substance that occupies space and it has weight or mass. Now, when you look at the question, it is asking us, the first question is, we need to state any two basic units of matter. The basic units of matter are, matter can either be an atom or molecules or ions. So first question, you name any two basic units of matter. So any two of the three qualifies as the answer. B, suggest two pieces of evidence which shows that matter is made up of tiny randomly moving particles. The evidence is 1, diffusion, the movement of particles from a region of higher concentration to a region of lower concentration. That is enough evidence to show that matter is made up of small particles, tiny particles which are always moving. Then apart from that, crystallization, the formation of crystals in a solution. That is also another evidence which can show us that matter is made up of tiny random moving particles. Dissolving, the process by which a solute disappears in a solvent. So that is also another evidence. Osmosis and Brownian motion. Question 3. Question 1, part C. The diagram below represents one of the physical states of matter. So we have that diagram. Then name the physical state of matter and explain why it has a fixed volume. When you look at the way the particles are arranged in that diagram, we can easily recognize to say that is a liquid. The explanation is that particles are closely packed and there are forces of attraction between the particles. Remember to tag in your friends and relatives so that they can also join in the watching. Don't forget to send us your comment as well as your questions if you have any. Tell us the place where you're watching from. We move on to question 2. Each of the following statement is incorrect, but if one scientific term is replaced by a correct one, the statement then becomes true. Identify the wrong word term, underline it, and in the space provided write the correct word. A. Condensation is the change of state of matter from solid to liquid. When we look at that statement, the word which is incorrect there is the term condensation, because condensation is not the change of state of matter from solid to liquid. The correct term there is melting. When a substance changes from solid and it goes to liquid, the change of state that occurs there is melting. Another word that you can use in place of melting is fusion. B, the basic unit of matter that exists in sodium chlorides are molecules. In that term, the word which is not correct there is molecule, because the basic unit of matter that exists in sodium chloride are not molecules, but ions. Why do we say ions? Because it is the ions, the sodium ion and the chloride ion, which get attracted and form a compound which we call sodium chloride. C, isotopes are compounds with the same molecular formula but different structural formula. When you look at that definition, it is very incorrect, because isotopes are atoms of the same element, having the same atomic number, but different mass number. Now, when we talk about same molecular formula, but different structure formula, we are not talking about isotopes, but isomers. So the incorrect term in that statement is isotope, and the correct one is isomers. D, calcium hydroxide is classified as an amphoteric substance because it dissolves in sodium hydroxide solution. The incorrect term in that statement there which we have is calcium. Calcium or hydroxide cannot be classified as amphoteric. The correct term which we can replace there is aluminium or zinc. 2A, zinc and chlorine bond covalently. Bond, the joining of atoms in order to form compounds, to form molecules. Now, when we look at the compounds that we have, the elements that we have there, we have zinc and chlorine. Zinc is a metal and chlorine is a non-metal. Definitely the two cannot bond covalently, because a covalent bond only exists in non-metals. So the bond that exists there is an ionic bond or electrovalent bond. So the correct term that we can replace with covalently is ionic or electrovalent. Question 3. Send your comment, viewers, and also the questions if you have any on the topic that we are looking at today. Question 3. Two elements A and D are represented by the notation shown below. We have 23A and 23A11, then 16-8D. Question A. Draw electron shell diagrams to show the arrangement of electrons in the atom of A and D. So to start with here, we'll look at A. So A has an atomic number of 11 and a mass number of 23. So in this question A, it is asking us to draw the electron shell diagram to show the arrangement of electrons in the atoms of A and D. So before we look at, we draw the electron shell diagram, it's important for us to also establish the number of electrons that are present in atom A as well as atom D. So on atom A, we have two numbers, 11 and 23. 11 is the atomic number, and the atomic number symbolizes, or we can define it as the number of protons that are present in an atom. Then 23 is the mass number, and the mass number represents the sum of protons and neutrons that are present in an atom. An atom has 3 subatomic particles, and these subatomic particles are electrons, protons, and neutrons. So our main concentration here is not on the number of protons or the number of neutrons. Our main concentration here will be on the number of electrons, because it is the number of electrons that will give us a guide on how we're supposed to arrange them in an electronic shell diagram. So since the number of proton here is equal to 11, and this electron is electrically neutral, which means that the number of electrons also is equal to 11. The number of protons and the number of electrons in an atom are always equal. So in this case, we'll start by drawing the electron shell diagram for atom A. So the first shell that is closer to the nucleus accommodates only 2 electrons. So the 2 electrons are here. Then we go to the next shell. So when you look at this, we can also say electronic configuration for this atom is 2, 8, 1. So which means that in the second shell, we're supposed to have 10 electrons there. Then we are remaining with 1 electron in the outermost shell. So the last shell, which we call the outermost shell, will accommodate the last electron. So atom A has 11 electrons, and this is the way we are supposed to arrange them in an atom. Then we move on to atom D. D has an atomic number of 11, mass number of 16. So the number of protons in D here is equal to 8. Why? Because the atomic number is the number of protons in an atom. Then, since the number of protons is always equal to the number of electrons, so it means that D also has 8 electrons. We are not going to look at the number of neutrons. Now, let's come up with the electronic configuration for D. So the first shell accommodates 2 electrons, the next shell accommodates 8, and the last shell will accommodate 8 as well. But if you look at the number of electrons which we have here, they are 8. So the next shell, which is the second shell, will not accommodate 8 electrons, but instead it will accommodate 6 electrons. So which means that when you add this 6 plus the 2, it will give us 8, which is equal to the number of electrons in D. So we'll represent this using this electron diagram. The first shell will accommodate 2 electrons. Then we move on to the next shell, which will accommodate 6 electrons. So the outermost shell, which is the last shell, only has 6 electrons, which means that it is not completely filled. Then we move on to 3B1. When atoms of element A and atom of element D react together, what type of bond occurs? There are three types of bond which exist. One, we have a bond which we call covalent bond, and two, metallic bond, and three, ionic bond. A covalent bond exists between nonmetals. An ionic bond exists between a metal and a nonmetal. A metallic bond is a bond that exists in metals. So when you look at the atoms which we have here, looking at the number of electrons which are there, atom A has 11 electrons, which means that for it to be stable, it has to lose 1 electron. And the element that usually loses electrons are metals. While atom D has 8 electrons in its outermost shell. And because it wants to be stable, it either has to lose 6 electrons or to gain 2. So the easy way is to gain 2 electrons. So which gives us an idea that atom D is a non-metal. So because the atom A loses and it's a metal and atom D gains, it means that the type of bond which can be formed between the two atoms is ionic bond. So type of bond is ionic bond. Then B2, using the dot and cross diagrams, show the structure of the compound formed between A and D, showing all the electron shells. So we move on to B2. We've already answered B1, which is ionic bond. The other name for ionic bond is electrovalent bond. Then B2, compound. We are using the dot and cross diagram to show the structures of the compound formed. So in this case, what is going to happen is A has an atomic number of 11. So which means that this is going to lose an electron. And when it loses an electron, it becomes an ion with a positive charge. While D has an atomic number of 8, and it is going to gain 2 electrons. When it gains 2 electrons, it becomes an ion with a negative charge. So it will be 2 minus. 2 means the number of electrons it has gained, which means that the number of electrons in this ion will be more than the number of protons by 2. So this compound which is formed here is an ion in A, and in D also the compound formed is also an ion. So when you represent it using the electronic structure, A is going to look like this. It will have the first shell with 2 electrons and the next shell with 8 electrons. While D the first shell will have 2 electrons, the next shell will have 6 electrons. But in this case, when you look at this D, it needs 2 electrons. And A is only able to donate 1 electron. So which means that we'll need 2 atoms of A to donate 2 electrons to D so that D can also be stable. So in this case, what will happen is 2 atoms of A will lose an electron each. And when that happens, these electrons will be acquired by D so that D can become stable. So the structure in this case will be The structure in this case will be like this, 2 electrons. Then plus. Then this will be atom D. We can use the dots in this case. Then so what happens in this case is that these 2 atoms, atom A and atom A, will lose an electron each, and then these 2 atoms which have been lost by 2 atoms of A will be picked by D to form an ion. So this is an ion, that is an ion, and this is how you use the dot and cross diagram. So the dot is on the D and D. A, we've used the cross, the crosses to symbolize the electrons. C, state any 2 physical properties of the compound formed between A and D. So the physical properties of the compound formed between A and D is that 1, it is soluble in water and insoluble in organic solvent. 2, it has a high melting and boiling point, conduct electricity when it is in molten state. We move on to question 4. When carbon dioxide gas is bubbled through aqueous calcium hydroxide, which is lime water, the following reaction occurs. Calcium hydroxide aqueous plus carbon dioxide will give us calcium carbonate plus water. A, write a Wade equation for the reaction. So the Wade equation is calcium hydroxide plus carbon dioxide will give us calcium carbonate plus water. So this is the Wade equation. Calcium hydroxide plus calcium carbon dioxide will give us calcium carbonate plus water. We move on to B. If 1.2 decimeter cubed of carbon dioxide gas measured at room temperature and pressure was bubbled through excess calcium hydroxide solution, 1. Calculate the mass of calcium hydroxide solution which reacts. This is a volume mass calculation or a mass volume calculation. So this question is extracted from a topic which is known as mole concept. And in this case, we are going to look at the volume of carbon dioxide, comparing it to the, we'll compare it to the mass of calcium hydroxide. So what we'll do in this case, we'll pick what is asked from the question and start solving. So calcium hydroxide calcium hydroxide to carbon dioxide. So in this case, when you look at the question, we've been asked to calculate the mass of calcium hydroxide, but what we've been given is the volume of carbon dioxide. The volume is 1.2 decimeter cubed. So we need to first of all find the mass of calcium dioxide. So first of all, what we do here is we first of all need to take the ratios. 1 mole of carbon dioxide was produced against what mass? So the mass of calcium which was produced here is calcium. We get the relative formula mass of calcium hydroxide. So calcium 1 times 40, then oxygen will give us 2 multiplied by 16, which is the mass number. Then hydrogen 2 multiplied by 1. So the first one will give us 40 when you multiply that. The second one 32. The third one will give us, which is hydrogen, it will give us 2. When you add that, you get 44. So 44 grams gave us 1 mole of carbon dioxide. So let's form this. We say mass to volume. This is how we are going to work it out. So 44 grams of calcium hydroxide gave us 1 mole. 1 mole of any gas at room temperature and pressure is equivalent to 24 decimeter cubed. So 24 decimeter cubed. Then, what is the mass of calcium hydroxide which will be produced from 1.2 decimeter cubed? We don't know. So in this case, we find the value of X. So X will be equal to 44 grams multiplied by 1.2 decimeter cubed over 224 decimeter cubed. 44 grams multiplied by 1.2 decimeter cubed divided by 24 decimeter cubed. Decimeter cubed and decimeter cubed will cancel. When you divide and multiply this, you get your answer, which is equal to 3.7 grams. And remember, we are looking at mass, so the answer has to be in grams. So the first question is done. Then we move on to the next question. Calculate the mass of calcium carbonate formed. So in this case, what we are going to do is we'll also do a volume to mass calculation. So here we'll look at carbon dioxide. We equate it to calcium carbonate. Then what is the volume of carbon dioxide which was used during the reaction? 1 mole, which is equivalent to 24 decimeter cubed. This gave us the relative molecular mass for calcium carbonate is calcium 1 multiplied by 40, and then carbon is 1 multiplied by 12, then oxygen is 1 multiplied by 16. When you multiply this and add, it will give us the sum of 100. So 100 grams. Now, what if 1.2 decimeter cubed was used? What is the mass of calcium carbonate which will be produced? So the mass will be X. So X in this case, we find the value will be equal to 1.2 decimeter cubed multiplied by 100 grams divided by 24 decimeter cubed. Decimeter cubed and decimeter cubed will cancel or will divide. When you divide that, the answer that you get at the end of the day will be 5.0 gram. So X will be equal to 5.0 grams. So question 2 is done. Then question 3. Describe what would be seen as the carbon dioxide gas is bubbled through aqueous calcium hydroxide. Calcium hydroxide is lime water. So the identity of carbon dioxide, the identity test for carbon dioxide is that it turns lime water milky. So what will be seen in there is a colorless aqueous sodium hydroxide will turn into milky, or white precipitate will form. That's what will be seen in there. We move on to question 5. The following table shows some information about the second member in the respective homologous series. Complete the table by filling in the correct information. This question is coming from organic chemistry. We are able to see alkanes in the first column. The second column, we are able to see ethanol, and the structure that is, the third column, we are able to see a structure which is displayed there. But then when you look at the question, you should bear in mind that you have to look at the guiding parts, which is the second member in the homologous series. Now, what is homologous series? These are a series of compounds in which member of a family or group differ with only CH2. So when we look at the first name of the homologous series, alkane, we've been given the guiding part there. So alkanes, the name of the member, the second member of alkane, if the family is alkane, the name of the second member is propene. Alkenes are hydrocarbons that are contain carbon-to-carbon double bond. So we cannot say methanol is the first member of the alkene family, because methanol has only one carbon, while the second one, which is ethanol, has got 2 carbons. So the one which has got 2 carbons is the one which stands as the first member of the alkene family, which has carbon-to-carbon double bond. So the displayed structure formula for propene in that case will be, we'll first of all put our carbon atoms, but bear in mind that in the chain we need to have a double bond present there. So I'll put our double bond there, or you can also put your double bond somewhere there. So this is how it's going to the structure will look like that, or the structure can also be like this. You can put the double bond in the first 2 atoms of carbon. So if you put the double bond there, it will look like that. So the answer can either be this one or that one. It doesn't matter where you place your double bond, but the double bond has to be present between the carbon atoms. So propene is the second member of the alkene family. Then we move on to the next one, which is we don't know the homologous series, but what we are able to see is the name of the member. The name of the member there is ethanol. Ethanol is an alcohol. Why? Because of the presence of NOH at the end of ethanol. So the homologous series to which ethanol belongs to is alcohol. Alkanol or alcohol. That is the homologous series. Then the displayed full structure formula of ethanol is this. First of all, before we talk about the displayed structure formula, you should know that alcohols are organic compounds which contain OH as their functional group. So in the structure formula, there should be an OH which is present there. So the structure there should be ethanol has got 2 carbon atoms, so it will be like that. Then we'll have 1 carbon atom, hydrogen atom, and 1 hydrogen atom, and another hydrogen atom. Then 1 hydrogen atom here, 1 hydrogen atom, then O, then H. Remember that when you write the displayed structure formula for alcohols, there should be a bond between oxygen and hydrogen. When you just write OH like that, it doesn't really look okay, because we are looking at the structure which is formed there. Now that structure has to be represented by bonds. So there is a bond that is present between oxygen and the hydrogen. Then we move on to the last part. We don't know the homologous series. We also don't know the name of the member. But the displayed full structure formula is there, which is given there. So when we look at that, there are things that have to guide us when we look at the structure. The C and the C. The 2C means that there are 2 carbon atoms that are present there. Then there is a double bond on the last carbon with oxygen, and then OH. So looking at this only, COH. This is the functional group of carboxylic acids. So the homologous series of that structure which is represented there is carboxylic acid or alkanoic acids. So the homologous series is the carboxylic acid. Then the member of that carboxylic acid is the ethanoic acid. Why? Because there are 2 carbon atoms present in there. We can also write the structure of ethanoic acid as in molecular structure. So the molecular structure will be CH3COH. Mukuka Simeo, I can see you are enjoying the viewing, and Pule Kumalinga, please feel free to also send your comments. Don't just watch and enjoy. We move on to question 6. The diagram below shows part of the periodic table. So, part of the periodic table. So that is the periodic table, and we have the questions that follows. So before we look at that question, can we please take a quick break? As we go on break, please remember to tag in your friends and your relatives so that they can also join in the watching. Don't forget to also send us your comments. Don't just watch, but send your comments and as well as questions so that we can attend to you during the session. Thank you.
I told the bus driver that I work hard for my money, so it better gets to Chipata.
Yeah, that's right. That's what I told him.
Yeah.
Weather, drama nizingono, or nizambili.
Tituma. And he kept trying to tell us something, but I was like, Ukagamba, Tiloa.
Cause cash money yeve across Zambia.
Tituma. At Basi and Kuchpat. The end of South Africa. Hello, what?
Run, K-Star, run! You got the bus.
Sending money doesn't have to be this dramatic. Open an MTN mobile money account today and send money to friends and loved ones across Zambia instantly. Dial *303# to send money with MTN, Zambia's #1 network. With MTN mobile money, Tituma.
MTN, everywhere you go. Hello! This is all you need to know about data bundles. Like when you need airtime to make calls, you need data bundles to browse the internet, send and receive photos on Facebook, chat on WhatsApp, send emails, listen to music, and many other things. Data is measured in bytes, kilobytes, megabytes, and gigabytes. These are a bit like money, and just like your bank balance, your MTN account has a data balance that you can use to buy data bundles ranging from 5 megabytes to 20 gigabytes for daily, weekly, and monthly subscription. To buy a bundle, dial *335*1#.
From sending emails to browsing or watching online videos, many of the things you use depend on your device's functionality and network capability. Entry-level devices have limited data usage, whereas smartphones and computers have limitless data usage. The longer you spend online, the more data you use.
Sometimes you feel like your data is running out really fast. That's because today's modern technology and higher definition content require and use up a lot more data. No need to worry. Data can be managed to work for you by minimizing on the number of apps that automatically update themselves and turning off your data when not in use. Make sure you use data bundles to browse the internet. When your bundle is depleted, you will be billed from your airtime. Perform regular data balance inquiries by dialing *335*3#.
Welcome viewers to our session. Charlie, I've seen your question there where I need to explain about the 2N2 rule. You join me at 16 hours in the exam tip session. I'll be able to explain that. Thank you. So we're on question 6. The diagram below shows part of the periodic table. So we have the periodic table, but before we look at the question, you need to know that a periodic table consists of periods as well as groups. So on a periodic table, we have groups, and these groups are 8. Now, what determines the element to be placed in a particular group is the number of electrons that it has in the outermost shell. And we also have the rows. The rows are what we call the periods. And what determines an element to be placed in the period is the number of shells that element has. So state the name of the element from this part of the periodic table, which A forms a univalent cation. So to start with, maybe it's important to also understand what a cation is. A cation is an atom that has lost electrons. So in this case, when you look at the periodic table, you find that the metals are the elements that have a tendency of losing electrons. So univalent cations, univalent or monovalent cations are cations that loses only one electron and becomes an ion with a positive charge of 1. A divalent cation is a cation that loses 2 electrons and becomes a cation with a charge of 2. A trivalent cation is a cation which has lost 3 electrons and it becomes a cation with a charge of 3. So from the periodic table that we have there, the element which forms a univalent cation is elements that are found in group 1 of the periodic table. Because elements in group 1 of the periodic table have only 1 electron in the outermost shell. And because it is the tendency of atoms to be stable, they usually lose electrons or gain electrons so that they have an outermost shell which is fully filled with electrons. So that the cation, the univalent cation in this case can be lithium or sodium or potassium. Move on to B. React most vigorously with cold water. The element which reacts vigorously with cold water is potassium. Lithium, sodium also react vigorously with water. But the question here is asking us to identify the element which react most vigorously with cold water. Now, when we talk about most, we need to look at the element which react mostly, and that is potassium. Why? Because the reactivity in group 1 increases as you go down the group. Now, in this case, you are not supposed to write the answer using symbols. You are supposed to write the answer by writing the name of the element, because the question is asking you to state the name, not the symbol. So, react most vigorously with cold water is potassium, not K, but potassium. C. Forms oxide of formula XO and X2O, where X represents the chemical symbol of the element. So in this case, the one which forms oxides, first of all, before we talk about the element or the name of the element which forms the oxides, it's also important to understand what an oxide is. An oxide is an element which is formed, or it's not an element but a compound which is formed when oxygen combines with any other element. An oxide can combine with a metal and form a metallic oxide. It can also combine with a non-metal and form a non-metallic oxide. So from the question here, the name of an element which forms oxide of formula XO and X2O is helium, or we can also say neon, argon, or krypton. D. State the name of an element from the part of the periodic table which does not react with oxygen. Oh, just a minute. Answer for question C is copper. When you look at copper, it is there in period 3. That's the answer for question C. Now, neon, helium, argon, which these elements which are in group 8 of the periodic table are the ones which do not react with the oxygen. These elements are stable and therefore they are unreactive. So the answer for D is helium, neon, argon, or even krypton. While for C, the answer is copper. Why do we say copper? We have the symbol which is XO, and we have the symbol X2O. So copper has so many valences. We have copper 1, we also have copper 2. So if the copper which is used in that case is copper 1, the formula which is formed is XO. If the copper which is used is copper 2, then there is copper 2. If the copper which is used is copper 2, then the formula which we have is XO. If the copper which is used in this case is copper 1, then the formula is X2O. Question 7. Solutions of hydrochloric and sodium hydroxide are mixed together and they react as shown below. So we have sodium hydrochloric acid and sodium hydroxide. These are, so hydrochloric acid is an acid, sodium hydroxide is a base, an alkaline. A. Write a balanced chemical equation for the reaction. So balanced chemical equation in this case will be sodium hydroxide aqueous plus HCl aqueous will give us sodium chloride plus H2O. So when a reaction takes place between a base and an acid, and in this case, this is a strong base, which is the sodium hydroxide, and the hydrochloric acid is a strong acid. What is formed there is a salt, which is sodium chloride, and water. So this is the balanced equation for the reaction. So you can look at it. We have one sodium. We have one oxygen. We compare the elements on the reactant side and the product side. We have two hydrogens, and one chlorine. Then B, state the name of the type of reaction and write an ionic equation for it. That type of reaction is called neutralization reaction. This is a type of reaction in which a base reacts with an acid to form a salt and the water. Ionic equation for the reaction. Here, when we write ionic equation, we just focus on the substances that exist in aqueous state. So sodium aqueous, hydroxide minus, plus hydrogen aqueous, chlorine. This will give us sodium plus chlorine plus H2O. So this is the ionic equation for the reaction. Describe how crystals of sodium chloride can be obtained from the solution formed during the reaction. The crystals, number of marks there, 2. You should take note of that also when you're answering questions. First of all, you have to evaporate the water which is inside the solution by heating the solution which contains sodium chloride and water. Then after that, cool the solution. When you cool it, then filter and crystallize it and allow the solution to cool. When you allow the solution to cool, the crystals will form. So the first step is evaporate the water by heating until the solution becomes concentrated or saturated. Then the next thing is cool the resulting solution to form crystals. Once the crystals form, then you get the sodium chloride crystals. We move on to question 8. When hot magnesium metal is introduced in a jar containing carbon dioxide gas, the carbon dioxide is decomposed and the following reaction occurs. We have that reaction. In this reaction, both oxidation and reduction occurs. A. What name is used to describe a reaction in which both reduction and oxidation occurs? That is a redox reaction. B. State with reasons which substance is oxidized and which substance is reduced. B1, substance which is oxidized in there. The substance which is oxidized is magnesium. Reason, because oxygen is added to magnesium. Oxidation is the addition of oxygen to a substance. So magnesium is oxidized. The reason is because oxygen is added. Then 2, substance which is reduced there, carbon dioxide. Why is carbon dioxide reduced? Because it loses oxygen to magnesium. C. Which substance is the reducing agent? C. The reducing agent is magnesium. Why? Because magnesium has been able to accept the oxygen coming from carbon dioxide. D. Classify the two types of oxides from the equation above. Classify the two types of oxide from the equation above. The two types of oxides are, one, first of all, before we talk about the two types of oxides in the equation, know that there are four types of oxides. We have one, acidic oxides. These are oxides of nonmetals. And then we have basic oxides. These are oxides of metals. Then we have amphoteric oxides. These are oxides which have both acidic and basic characteristics. Then we have neutral oxides. Neutral oxides are oxides which have neither acidic characteristic nor basic characteristics. So classify the two types of oxides from the equation. Carbon dioxide is an acidic oxide. Magnesium oxide is a basic oxide. Section B. Okay. Due to time, we cannot go to section B, so we will end here. Thank you so much for tuning in to MTN TeleSchool. My name's again, Mutakela Inutu from Lusaka Girls Secondary School. It has been a pleasure revising with you. Look out for the next session during the day, and don't forget to inform your friends and your relatives to like the MTN Zambia Facebook page so that they can also enjoy the watch. Thank you so much and stay yellow. Goodbye.
Tiende pamoja ni mtima umo. 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 Tiende pamoja